Hello, everyone. Welcome to today's session about navigating the inventable Kubernetes breaking changes behind the scenes. I am Marko Mudrinić. I am a senior software engineer at Kubermatic. I am also a SIG KC Infra Tech lead and sub-project lead for the Kubernetes release engineering. Aside from that, I am a CNCF ambassador as well. Before we get started, one content warning, and it is about that the focus of this talk is the core Kubernetes, also known as Kubernetes/Kubernetes. Different sub-projects under the Kubernetes umbrella, think of projects like Ingress Nginx or Cluster API or any other project can and will probably do implement their own policies. So the focus here is just the core Kubernetes. And before we get started, let's think a little bit about what's a breaking change. And the answer is, it depends. Different projects will define breaking change in a different way, and some of them might be more restrictive, some of them might be less restrictive, but it really depends. And if you try to find some definition, it's not really easy, but I found one on the website called Wiktionary, and it says, a change in one part of a software system that potentially causes other components to fail occurs most often in shared libraries of code used by multiple applications. But I believe we can simplify this. And if we ask users what they think, mostly we will get answer that the breaking change is a change that's not backwards compatible, or in other words, that requires an user action upon upgrading. And I think this is something that we encountered many times in a lot of different cases. And I think we can all agree that we can split breaking changes into two different categories. We can talk about breaking changes that have a mitigation. So something has been broken, you need to take some action, you can't just upgrade and be happy with it. There is something that you need to do, but it's not end of the world. You can still use the feature that you're used to, just in a little bit different way. And there are those different breaking changes that are much more serious and maybe what we can consider the very real breaking changes, and those are that don't have a mitigation, that the feature is just gone and there's no replacement. And very fortunately for Kubernetes, a majority of breaking changes that we had over the time has been in this first category that had a mitigation. And we are going to see some examples today. First of all, it's important to know how those changes are classified when we are talking about Kubernetes. And in Kubernetes, you will be able to find those changes as removals and major changes. You can find those in many different places. There's a blog post series called Kubernetes Removal and Major Changes that's going out about a few weeks before the release. So, for example, if the release is scheduled for August, then somewhere mid-July there will be a blog post available that's going to recap all the important changes. There are also blog post series that's called Sneak Peek that's also going shortly before the release, and that contains stuff that will be changed and that's important for you to know. The release announcement blog post, of course, and for the end, the changelog. You probably have seen it many times, and the legendary urgent upgrade notes that we are always scared about, but that contains something that you need to be aware of. And of course, in the changelog, it's very important to evaluate it. Not all changes might be applicable to all users, for especially if you are running on a cloud provider, some managed offering. Change in a kubelet CLI or some flag might not be interesting to you, but some other change like the API has been deprecated is probably much more important to you. And this is how it looks like. So this is in the changelog. This is, for example, an example of the change. So there has been some environment variable. Now it works different, and you need to take the action depending on what behavior you want. And this is example of the blog post series that I have been talking about. So it contains, like, explains the policies of Kubernetes, something we will see today here as well, and then goes into details about each change that's important and that's breaking in a way. One problem that we have observed for a long time is that people are usually get aware of when something is removed, when that actually happens. And I want to raise awareness for here about that, is that before a feature is removed in Kubernetes, it has to go through a very strict cycle that's called the deprecation cycle, where the feature is marked for removal, and then after some time and after there's alternative, if it is possible, and only after that the feature is removed. People are usually not aware of that, and they only find it out when they upgrade the cluster and something is broken, but it's really important to take a look at the deprecations. The best way to find deprecations is the changelog. Those are sometimes in the blog post, but sometimes not, but the best place to find information about deprecations is the changelog. Again, the same note applies. Not all deprecations will be relevant to you, but it is the best to have some idea of what's going to be eventually removed at some point. And now let's talk a little bit about why does Kubernetes call the breaking changes differently. Like, why we call them removals and major changes, or urgent upgrade nodes. Let's see a little bit about that. So there's two factors to that. There's philosophical factor to that, and there's the technical. And if we talk like in the philosophical way a little bit, we can say that it's impossible to advance project without breaking changes. So at some point, we really have to make those changes. And why is that? Like, you might ask, so we can maybe add a new feature that's doing the similar thing as the previous feature. Why do we need to remove the previous feature? And the most important reason is the project healthiness and maintainers. If maintainers have to maintain the feature that two different features that are in a way same and that provide the same functionality, that's a lot of work for them. We have to remember what is not often said is that Kubernetes is in large maintained by people who are doing that on their own free time, that are not sponsored by their companies, and they do that when they can. They are taking away time from their families, friend activities to make the Kubernetes project better for us. And we can't really ask them to maintain a lot of different features that are actually doing the same thing. So eventually, when something new and better comes, we have to get rid of it. The other thing is that, generally speaking, having the project with way too much code and stuff like that is prone to a lot of different features, a lot of different problems, a lot of different potential vulnerabilities and stuff like that. So having a more clean code base is something that can help a lot with the project well-being. And of course, if a change has a mitigation, is it truly a breaking change? That's something that can be debated. In most of cases, we can say that it's breaking to the user, but we consider if there's a way to mitigate it, to save on our maintainers and to help them, it's better to do it. And from the technical side, the Kubernetes is a very complex system with many components, and a lot of those different components are versioned in a different way. So you might see that some different components are taking on breaking changes more often. For example, the APIs. Like, for components, they're pretty much well known and they don't change too often, but maybe some CLI flag or configuration property. APIs tend to change more often because the mechanism for versioning them or for introducing the new of them can be done a little bit easier than for other components. And there is one common question that is arising all over again, and especially when we started removing the APIs, and this is, should we have Kubernetes v 2.0? That's a very good question. And it's very complicated one because the Kubernetes is a very complex system. We can maybe even consider it as a microservice architecture where you have a lot of different services, and when they're all, some of them are versioned in one way, some of them in another way. So there's that too. And the other thing is like, what would that cause? Like, what would, as a user, for example, if you would create Kubernetes v2, that would also mean that, for example, some tools, how will tools handle that? How will, for example, all the materials, documentation, everything, a lot of users will be confused. Can they apply that to V2? What, is it risky or something like that? A lot of questions comes, a lot of confusion, and then it's bringing a whole lot of problems that are often not thought about well and that are important to have in mind. And we already have the procedures, like being able to version the APIs so we can have different API versions, and for example, being able to have like different config files following the same pattern. And for the end about this is that we wouldn't really consider Kubernetes v2 unless we have some really major change. Let's say API server doesn't exist anymore, right? So this would be a very significant change. Or we don't accept YAML files anymore. But all those changes that we had over the time, they really didn't change the core Kubernetes. The architecture is the same all over the years. The way of using it, like kubectl, didn't went through that many changes that completely changed it over the time. It's the pretty much kubectl we have been using for years. So this is the reason why we don't have Kubernetes v2. And now to see some example of removals. Like most often we have those three. So removal of API version, removal of CLI flag and or environment variable, and removal of built-in features. And for them, in most of cases, we had a mitigation. For API version, usually there's a new API version available. For removal of CLI flags and environment variables, in most of cases, there have been a configuration file that have replaced those, and that you can use instead. The most notable example there is, for example, kubelet. We have similar for kubeproxy and for some other components that CLI flags have been removed in the favor of a config file. And the other one is removal of built-in features. In a lot of those cases, we have an external feature available. Perhaps the most notable example here is, for example, Dockerstream. There have been external projects, I believe, Cry, Dockerstream, or something like that, that allowed you to continue use Docker if you want. Or in some cases, you can build on your own some webhook or something like that that's going to replace the built-in feature. And in a lot of cases, community does that if there is really need for that. But one interesting here and one interesting change that a lot of people tend to suffer a little bit is the removal of API version. And I would like to do a very short demo here. So what is important to know is that when we are talking about removing an API version, Kubernetes has a mechanism for converting from one API version to another and then back again. So if you're using a deprecated API version, the Kubernetes is actually going to convert that object to an API version that's not deprecated, that's actually the stable one, and you store the object with that API version, and even if you ask for that object, it's going to give it back to you in the new API version. So if I have something, so I have a cluster here that's running Kubernetes v131.2. And this version of Kubernetes had the flow schema resource that is in v1 beta 3, and that is deprecated. And it also has v1. So if I take this v1 beta 3 and apply it, it will give me a warning. It will say it is a deprecated and it will be available in 132 plus. Please use v1. But it has created it successfully. However, if I get this flow schema, so it is held for strangers, It's going to work. But if I get it in the YAML format, I am going to see that it returned me v1. But I actually created v1 beta 3. So for most of API removals, it is pretty much Kubernetes going to do the work of you. How you can update manifest? Well, you can consult what Kubernetes did for you, put that in your new manifest, and just continue to work with it. Even if you need, for example, to compare something, like you want to get it in the previous version, there's option for that as well. You can use kubectl with that. You can provide it with the resource, then the version, and then the API group, and it's going to return you in v1 beta 3 with a warning that it has been deprecated. So after a small demo that I hope you enjoyed, we are going to talk a little bit about the anatomy of a breaking change, or of any change, actually. So what breaking change has to go through is pretty much what any change has to go through. And it looks like this. So any change in the Kubernetes project, especially the significant one, has to start with a proposal. Something that we call the Kubernetes enhancement proposal, or in short, KEP. The KEPs are living on GitHub in the Kubernetes/enhancements repository, and it's a pretty long and detailed document that contains things like the timelines, the proposal itself, the motivation, if there are alternatives that were considered, the implementation, the test plan, and for the end, something that's called the production readiness review. So the way it works, like how the change happens, is that someone is proposing it, then the maintainers are going to review it, and then the special group of maintainers who have a lot of experience with the Kubernetes projects are going to look at it to make sure that it makes sense, that it is okay for running it in the production, and to give their, like if they're happy with it or not, or if it has to be changed. So every change, like it, what is important to understand, that it didn't came out just like that. It has been actually evaluated with a lot of alternatives considered, with a lot of discussions to make sure that if we have to do something like that, that we really, really have to do it. After that, we proceed with the implementation, and after the implementation is done, we start writing the conformance test, doing the docs, the blog posts, and eventually publishing those. And from the release perspective, so how the release cycle looks like. The release cycle looks like that we start, that it takes maybe 13 to 14 weeks, depending on exactly what are, how it all goes together, and availability of people and other things, conferences like KubeCon. But in general, the very first thing is that there's the production readiness freeze, which is about 11 weeks before the release, where this team has to, where every proposal has to be reviewed and has a positive rating from the people reviewing. Then we have the enhancements freeze, which is about 10 weeks before the release. And if you want your feature to go into the release, this is the point where it must be implementable. Like, if your proposal is not ready to be implemented by then, is not approved, doesn't have all the necessary things that it needs to have, it's not going to end up in this release, maybe next one. And 5 weeks before the release is code and test freeze, where the code has to be done and merged, where test has to be done. And of course, if it didn't made by then, it's probably not going to end up in the release. Then about 4 weeks before the release, we start with publishing some of the blog posts and working on the docs and all the needed what is for the release. And at the end, we have our lovely release. Now let's talk a little bit about the policies, which is important as well. And the first policy that I want to start with is the Kubernetes deprecation policy. It is a very important one, a very detailed policy. It has maybe 11 rules with some sub-rules, but quite complex document that has everything that you need to know when for deprecating the feature and eventually removing it. As we said a little bit earlier, before you can deprecate the feature, before you can remove the feature, you actually have to deprecate it first. And what is for you important as a user is that in average, before you can remove the feature, it has to be deprecated for quite a long time. For general available features, it takes 12 months or 2 releases, whichever is higher. For beta releases, this is 3 months or 1 release. And for alpha releases, those can be removed at any time. And this is why is it very important to keep an eye on deprecations and to make sure that you're aware that something is eventually going to be removed. What is covered by Kubernetes deprecation policy? Those are APIs, flags and CLIs, features or behaviors, and metrics. Again, the information that I presented was average. Some of those might have some little bit different numbers, but in most of cases, it is very similar. And another policy that is important is the version skew policy. It is maybe not important as the deprecation policy, but it is interesting to keep in mind that you can have a skew when it comes to version between components in your cluster. If you're using the managed offering, not that important, but it's good to know that, for example, in reference to Kube API server, you can use Kube Controller Manager, Kube Scheduler, and CCM that's at the same version or one version prior to that. You can use kubectl that's one version newer than API server or one version older, or the same version, of course. And kubelet and kubeproxy allow that they are 3 versions older, 3 minor versions older than Kube API server. So this is something to keep in mind, and if you're interested, you can scan the QR code. Oh, sorry. Okay, but we didn't talk about the infrastructure, did we? So this is a little bit different, and it is very important to clarify this as well. The infrastructure of the Kubernetes project is not covered by the prior policies. In other words, there are no guarantees of any sort for the infrastructure provided by the Kubernetes project. So think about registry KTS, IO, DL KTS, IO, packages KTS, IO. None of those have actually guarantees. And why is that? That's because all of that infrastructure is first of all maintained by people who are volunteers and doing this in the free time. And for the other reason is that we are depending on the cloud providers and other providers donating the credits and their infrastructure where we can actually run that. If for any reason is there any change to that, we have with short notice or no notice at all to drop some part of infrastructure. We had unfortunately happening that at some point, we will see that as an example. So probably the one that you all encountered is the KTS GCR IO being frozen, so you all had to switch to registry KTS IO to continue. There was some information about that, it's some that give you time to move, but once we had to do it, it just happened. We were not able to do some, let's say, as long deprecation period as for a feature. And same goes for DLKS IO. This is another change. We were pretty much had to do that to adopt the CDN because serving all the binaries and everything became very expensive and we had to cut down the costs, and we just had to change to something CDN to be able to save us some money. And for that, we are very thankful to the Fastly for providing us a CDN services. And one more example of those changes is the Kubernetes legacy package repositories. We also had to do that, not only because of the cost reason, but because it became a huge burden for maintainers, and we needed something that's better tailored to Kubernetes projects, so we came up with a new solution, and we had just to drop the new one as soon as possible so that we can continue delivering you the releases. If we kept the old package repos, then we would have a lot of troubles, a lot of problems, and that wouldn't be nice to you also. It is some case where we had to say, okay, we have to stop doing the old one, we are continuing just the new one so that we can provide you the better quality. And this is the unfortunate part when it comes to infrastructure. A lot of changes have to happen on the short notice. And when it comes to the infrastructure, one last thing, what is important, if you use Kubernetes, mirror all the things. This is very important. Because of infrastructure being dynamic, it can become unavailable at any point because of any reason. You don't want your cluster to stop working. Mirror everything there. For example, for registry KTS IO, you can find it, its repos, some instructions, and there are also a lot of different places where you can find information how to mirror files or packages. It is very important to do that. You're first helping the Kubernetes project because we would get to save a little bit on the cloud cost, but you're also helping yourselves because if something would happen to our infrastructure for any reason, your cluster would not go down and your workloads would continue working, especially given there are no guarantees. And finally, what can you do and how you can prepare? Those are two questions that you might have after all of this. So the best thing that you can do is to stay on the top of the news, like follow the Kubernetes development, follow the change log, make sure you're aware of deprecations, make sure you're aware of some of the breaking changes. One thing that you can do is to follow us on social media. We have a profile on LinkedIn, on Twitter, on Blue Sky, so make sure that you follow us there. We try to post the most important information that might affect you. Also, one important thing is the Kubernetes Announce mailing list. It has just about 5,000 people subscribed to it. It is probably not very well known. I believe we have many more Kubernetes users. It is a low traffic mailing list, mostly critical information like CVs, releases, and some of the breaking things that might happen that are on short notice. And for the end, if you want to go into some nerdy details and learn more about how development is going on, there is a mailing list which is called Last Week in Kubernetes Development. It's mainly focused for contributors, but if you want to really learn what is going on every moment with the Kubernetes development, it goes out once in a week. There are some very wonderful volunteers who are tailoring it and collecting all the changes and stuff like that, so it goes into the mailing list format. So you can give it a try. There are links, there will be slides published later on. And one other thing that you can do is to provide the feedback on the proposed alternatives. The best way to do that is GitHub or the Kubernetes Slack workspace, so feel to join any of those. And when providing the feedback, please be mindful of the maintainers, please be mindful of the code of conduct, because those maintainers are spending a lot of time on our lovely projects, and let's make sure that we understand them and that we understand the intention of the changes, and then we try to provide the valuable feedback. Finally, when we say that, what's considered a good feedback? It's important to know that once something is about to be deprecated or removed, the reversal or major change is very unlikely. That's because we have seen some of the reason, like having to think of project healthiness, of maintenance well-being. So if they decided that it has to go, it is probably for a good reason, not just because they want to do it, but because it is important for the project. So it's important to focus on the alternative, to try it out on time, not to wait for the previous API or something to be removed, then to try something new, but to try it in advance to make sure it works, like in the deprecation period before removal happens, and to provide feedback to the maintainers so they know that it works well. And some of the changes that we have, some good examples, is the Docker shim, like one that we probably got affected by at some point. And we had to do that. There was the deprecation period. In 1.24, it was completely removed. And, if you came and said, yeah, we want Docker shim still, you would get the answer that it's not possible. But a good feedback was like people trying out, making sure the migration works properly, things like that. Same goes for probably the largest migration in the Kubernetes history. This is switching to external cloud controller managers or CCMs. It was you know, a lot of people were affected, but it was important to do that, and it was like, what would be the valuable feedback in such cases, like trying different external implementations, providing the feedback and making sure it works and getting ready on time. So we are just about the end of the session. Thank you very much for attention. Please use the QR code to leave the feedback about this session. I really hope that you enjoyed it. I really hope that you learned something new. And thank you so much for coming today. Any questions? Looks like no. If you have any questions, you can always reach out to me or anyone in the Kubernetes community on Slack. Thank you very much.